last 40 years, we've seen most of the impact in robotics coming in the manufacturing space, where in this chart I've put an axis along the autonomy, where you have a structured environment and task-specific robots, whereas now we're starting to see these new emerging technologies that are allowing robots to go out of the factories, start to operate in unstructured environments and be more general purpose. I think it's a very exciting time. And I'd like to talk a little bit about how the cloud can have a large impact on making our robots more capable. One of the things that the internet has done is it has provided a shared knowledge base for finding information, and that knowledge base can also be made available to robots. And how can they improve their performance when that capability is there? We've heard a lot about powerful distributed computing and client-server models, and you can have some things running on the local compute resources of a robot, but you can also have access to larger compute infrastructure in the cloud. And I think that offloading some of these expensive computations and also some of the data hosting and storage in the cloud will enable robots to make better decisions and also be more intelligent. And as was mentioned in the previous keynote, the intersection of the information that's available on the internet with a physical interface is going to enable all of these cloud-connected machines to log their behavior. Then we'll be able to apply machine learning and data mine the history of the executions of these robots so that all cloud-connected robots can become more intelligent.
So in field robotics, we think about technologies for natural environments where the conditions can be controlled, such as they would be inside a home or inside a factory, inside a warehouse, that kind of thing. The scale could be very large. It's not just hundreds of meters or kilometers, tens of kilometers, hundreds of kilometers. And typically there's very little structure. So I have just some graphics to show you the kinds of applications, and they're very large, from applications of air vehicles, ground vehicles of various kinds, things operating in farms and mines that do work on their own. So very large possibility in this area. So when we look, the key technology, as one of the attendants pointed out, is the question of perception, understanding what's happening around it and where is the vehicle. That's making very strong progress. There's still some need to be able to do this at a small form factor and a small cost. There's adaptation to conditions. These are things that we work on. If you have more questions, I'll be happy to talk about it. The main applications we see are in that people are interested in from the commercial side are getting some answers at the point of work. Okay, some things out there in a work area outside, and we want to be able to get some measurement in real time and possibly a refined measurement later. These kinds of things have the potential of dramatically altering the development business cycle and a whole bunch of things that could never be done before. So you'd be able to get measurements and get them in real time so that you could do something about these kinds of things. I think this, apart from all kinds of other practices of managing these industries, there's a chance to get data at a high spatiotemporal level that has not been possible before, and many people here are very aware of what we can do with big data. It's a chance for lots of opportunities that haven't been to date.
I'm very happy to hear the plenary talking about really emphasizing the assisted robots for elderly and possibly for disabled. So, indeed, we're at a tipping point for robotics. As Rich pointed out, there are a number of safer, human-friendly robots now available from a number of different manufacturers. We have lots of choices in terms of sensors, actuators, processors, and also powerful algorithms that are readily available, that are open, that are robust, ubiquitous connectivity, more sophisticated and natural user interface, and as James mentioned, cloud computing. So all this means that the closer human-robot interaction for a number of different applications are fast becoming a reality. And this convergence of technology really cannot happen soon enough, because there are population segments that can really benefit from this this technology. So for example, that for spinal cord injury, so there are over 300,000 spinal cord injured patients in the United States, and many more, of course, all over the world, with thousands added each year. And over 40% of the spinal cord injured patients actually lose the use of all four limbs, the quadriplegic or tetraplegic. So this number by itself may not sound huge, but many of those injuries occur when the patients were young, and the cost of care over the lifetime could be quite significant. And another population segments that could really benefit from this type of technology, of course, is people like me or some of you, the baby boomers. Indeed, the senior population will double, forecast will double over the next 2 decades. And so this type of robot assistive technology could really enhance the quality of life by affording greater sense of independence and also reduce the cost of care. And probably very important to most of us is that this could potentially allow us to age in our own homes. So what will be coming is now as our homes become more technologically advanced, more integrated, become smart homes, robots will be part of the appliance, and the robots will be talking to lights. Increasing lights will be smart lighting. There will be Wi-Fi connected, so we have robot lights. So you have even more robots to a refrigerator, to HVAC, heating, air conditioning system, as part of the Internet of Things network. However, I think the key issues that still need to be fully addressed is security. And privacy. We don't want to, none of us want to have a lot of, cameras, looking at us. And the sensors, would that compromise our sense of privacy? Of course, safety to human operator is critical. Interoperability. The industrial robot has done a lousy job of being interoperable. Actually, even for automation industry, there's very little interoperability. I think ROS is a robot operating system, and ROS Industrial are good steps in that direction, but it's still a long way to go. But interoperability is critical for different devices to work seamlessly together and easily. And open software, I think Nate will talk more about the open software, is also important to allow customized apps easily developed for different applications. But what's really important is to have robots that not just obey our command, but also the algorithms that allow us to teach and coach robot in a way that's like raising a robot, similarly to raising a child. I think that's the vision that we would like to see, and that's the field. The direction the field is progressing.
As you've seen, there's lots of robots coming into our daily lives. They're in industry and commercial applications, and they all need software to act intelligently and safely in our environments. So we've developed this software package called ROS, or the Robot Operating System. And this is a framework of tools that lets you talk to actuators, gather sensor data, and marshal all this information in an intelligent and efficient way to visualize information, do high-level planning, and basically coordinate all the complex actions that are required in a robotic system. So ROS has been around for about 8 years now. We've been working with people around the world to make this a reality. And fortunately, people have adopted this. This is not just in the research lab. Commercial entities are using ROS as well. And it's become pretty much the de facto standard when you think about developing a robotic application. So what makes ROS unique is its distributed architecture. Robots have been around for a long time now. ROS is only 8 years old. So we had to kind of think about where we wanted to advance the state of the art. And this came down to the fact that we saw all these bits and pieces that need to run on a robot. They need to be distributed either within the robot itself, across multiple PCs, or basically split across processes. So we wanted to give extra flexibility in terms of how you design and program a robot, and that's what ROS gives you. One of the nice things about ROS is that it's open source. So we're a nonprofit. We make open source software. We have a very active community based around ROS, and this gets us the ability to integrate lots of new features. A new sensor comes out, people build drivers for it. We have more eyes on the code, so this is really important when it comes down to software robustness. More people look at the code, they find bugs, they address those issues, and get it resolved really quickly, which is a really great feature. And as I mentioned, people use ROS to build businesses and products that they can sell. So even though we're open source, we have a really nice license that is friendly to businesses. And in fact, if you really wanted to, you could leave now, download ROS and try to sell it. No one's going to stop you. Probably not a great business model. So where has ROS been used recently? You've probably heard of the DARPA Robotics Challenge. In this case, 18 teams chose to use ROS to operate their arguably some of the most complex robots in the world to do disaster response in these outdoor complex environments. Nissan used ROS to control their automotive vehicle for mapping and navigation. Drone Code is this collaborative endeavor to promote the advancement of drone technology. And finally, NASA is using it on the Robonaut 2, which is a robot designed to aid astronauts in daily tasks on the space station. And in fact, ROS is actually running on the space station right now, which is kind of a cool thing. So basically, ROS is this easy-to-use framework. High schoolers, middle schoolers have used ROS all the way up to PhD students to get their doctorates, me being one of them. So it's been a great tool, and we really look forward to seeing how robotics advances in the near future and how we can help be part of that.